You've been told to fear the sky. You've been conditioned to imagine that beyond the quiet shimmer of distant stars, something is watching, waiting, preparing. The idea has been planted deep in your mind. One day, without warning, the darkness will tear open, and an alien force will descend on Earth. Cities will fall. Humanity will panic. Survival will hang by a thread. That narrative feels powerful. It feels possible. It feels almost inevitable. But pause for a moment and ask yourself a harder question. What if that fear survives not because it is realistic, but because it is dramatic? What if the very structure of the universe makes that scenario collapse before it can even begin? You've been fed spectacle for years. Giant ships hovering over planets, interstellar empires moving effortlessly between stars, civilizations crossing galaxies as if they were crossing oceans. It looks convincing on a screen. It feels convincing in your imagination. But imagination does not negotiate with reality. Reality answers to laws, and those laws are merciless. The universe is not a stage designed for invasion stories. It is governed by limits so strict, so unforgiving, that even the most advanced civilization would have to bow to them. Distance is not a minor inconvenience. It is an abyss. Energy is not an afterthought. It is a barrier that crushes ambition. Time is not flexible. It stretches into spans so vast that entire species can vanish between departure and arrival. Here is the truth that cuts through the noise. Physics is not impressed by your fears. It does not care about dramatic possibilities. It does not bend to cinematic imagination. The same principles that keep your feet on the ground, that keep planets in orbit, that keep light moving at its fixed speed apply everywhere. No exceptions, no shortcuts. You may feel small when you look at the stars, but what truly dwarfs you is not the threat of invasion. It is the scale and indifference of the cosmos itself. The laws that shape it are consistent, cold, absolute. They do not allow fantasy to sneak through loopholes. They do not reward civilizations for wanting something badly enough. The fear of alien invasion survives because it is exciting, because it gives the unknown a face and a motive. But the universe does not owe you a villain. It does not owe you a battle. It offers something far more severe: limitation. And once you begin to understand those limits, once you confront the raw structure of reality, the myth does just weaken. It begins to crumble under its own impossibility. You struggle to grasp how vast the universe truly is. Numbers are easy to say, but they are almost impossible to feel. When told that the nearest star system is more than 4 light-years away, the mind nods and moves on as if it were just another statistic, but that distance is not symbolic, it is brutally real. Light, moving at nearly 100,000 kilometers per second, takes more than 4 years to cross that gap. Nothing with mass can travel faster. Not a spacecraft, not a weapon, not an invading fleet. The speed of light is not just fast. It is the ultimate limit written into the structure of reality. You cannot negotiate with it. You cannot engineer around it. As an object accelerates closer to that limit, the energy required rises dramatically. Push harder, and the demand does not increase gently, it explodes toward infinity. The universe enforces this boundary with mathematical precision. The closer you try to get, the more impossible it becomes. Now stretch that understanding beyond the nearest star. The Milky Way galaxy spans about 1,000 light-years across. That means even light itself would take 100,000 years to travel from one end to the other. Imagine a civilization attempting to cross even a fraction of that distance. Even at 1/10 of light speed, an engineering challenge far beyond current human capability, the journey to a relatively nearby star could take decades. To targets deeper in the galaxy, centuries or millennia would pass. Distance in space is not like distance on Earth. There are no rest stops, no rescue services, no quick returns. Every kilometer must be carried through an environment that offers nothing for free. The vacuum of space does not slow you with friction, but it offers no fuel, no oxygen, no shelter. Everything required for survival must be transported from the beginning, increasing mass, increasing energy demands, increasing complexity. And then there is the scale beyond galaxies. The nearest major galaxy, Andromeda, is about 2.55 million light-years away. Even light, the fastest entity in existence, takes 2.5 million years to bridge that gulf. Any talk of civilizations casually hopping between galaxies collapses under that timescale. Species evolve and go extinct in far shorter spans. Continents shift. Stars are born and die. When confronted with these distances, the invasion narrative begins to lose its weight. The universe is not crowded in the way cities are crowded. It is sparse beyond comprehension. Stars are separated by voids so immense that even the fastest possible traveler would face journeys longer than the entirety of recorded human history. The sheer size of the cosmos is not just impressive. It is prohibitive. It turns ambition into endurance trials measured in thousands of years. It transforms exploration into a commitment across generations. Before imagining fleets descending from the sky, it is necessary to confront the scale that stands in their way, a scale that does not intimidate with noise, but with silent, overwhelming magnitude. There is a speed limit woven into the fabric of reality, and it does not bend for ambition. The speed of light is not merely a technical constraint, it is a structural boundary of spacetime itself. Every object with mass is locked beneath it. The harder you try to push a spacecraft toward that limit, the more resistance the universe applies, not through friction, but through energy demand. As velocity increases, mass effectively increases. As mass increases, the energy required to accelerate further rises even faster. Approach the speed of light closely enough, and the energy required becomes so enormous that it trends toward infinity. That is not a technological inconvenience. It is a wall. To move a small probe to a significant fraction of light speed would already require energy comparable to the total annual output of entire civilization. To accelerate something the size of a warship or an armada would require energy budgets rivaling planetary or even stellar scales. The romantic image of massive alien vessels gliding effortlessly between stars collapses under this calculation. Propulsion is not about desire, it is about physics. And physics demands payment in energy. Even if an advanced civilization had mastered fusion or harnessed exotic energy sources, the scale of acceleration remains punishing. Every kilogram added to a spacecraft multiplies the energy required. Shielding against radiation adds mass. Life support systems add mass. Structural reinforcement adds mass. Weapons, propulsion systems, communication arrays, each addition increases the burden. And the closer that craft tries to approach relativistic speeds, the more brutally the energy curve rises. Then there is the issue of deceleration. It is easy to imagine accelerating toward a distant world, but arriving intact requires slowing down. That means carrying additional fuel or devising equally powerful braking systems. Energy must be spent not only to leave home, but to arrive in control. Otherwise, the spacecraft becomes nothing more than a high-speed projectile, unable to stop, unable to maneuver, unable to conquer anything. Relativity introduces another complication: time dilation. At near-light speeds, time for the travelers would slow relative to the outside universe. While this might seem advantageous for long journeys, it introduces deep strategic instability. Communication with the origin world would become increasingly delayed. Coordination across interstellar distances would fracture under years, decades, or centuries of signal lag. An invasion force cut off from its origin by vast relativistic gaps would not operate as a unified empire. It would be isolated. The cosmic speed limit is not just a number. It is a guardian of separation. It ensures that stars remain distant from one another in practical terms, not just visual ones. No civilization, no matter how intelligent, can rewrite that constraint without rewriting the structure of spacetime itself. And as long as that structure holds, the fantasy of effortless, rapid interstellar conquest remains exactly that, a fantasy crushed under the weight of energy equations and relativistic law. Energy is not just a technical detail in interstellar travel. It is the central obstacle that turns ambition into near impossibility. Moving through space at extreme speeds demands power on a scale that dwarfs ordinary imagination. To accelerate even a modest spacecraft to a fraction of the speed of light would require an energy output comparable to the total production of entire planets over long periods. And that is only for acceleration. The numbers do not gently rise, they escalate violently as velocity increases. The fundamental equation for kinetic energy shows that energy grows with mass and the square of velocity. Double the speed, and the energy requirement does not simply double, it multiplies dramatically. At relativistic speeds, additional corrections from Einstein's equations make the curve even steeper. What seems like a manageable engineering challenge at low speeds becomes a monstrous demand as the target velocity approaches the cosmic limit. This is not a matter of better engines or smarter design. It is a matter of raw physical cost. Fuel itself becomes a crushing burden. Any propulsion system must carry reaction mass or harness external energy in some way. Carrying fuel increases the spacecraft, mass, which increases the energy required to accelerate it, which demands even more fuel. This feedback loop is relentless. The more ambitious the journey, the heavier and more energy-hungry the craft becomes. Even advanced concepts like antimatter propulsion, which promise enormous energy density, introduce staggering production and containment challenges. Producing enough antimatter to power a large interstellar vessel would require astronomical resources and flawless stability, as even a minor containment failure would release catastrophic energy. Then there is shielding. Interstellar space is not truly empty. It contains sparse particles and microscopic dust grains traveling at relative velocities that become deadly at near-light speeds. A tiny speck of matter striking a spacecraft at relativistic velocity would release energy comparable to an explosive impact. Protecting against this requires thick shielding or electromagnetic deflection systems, both of which add mass. More mass means more energy required. The cycle tightens again. Thermal management adds another layer. High-energy propulsion systems generate immense heat. In the vacuum of space, shedding heat is difficult. Radiators must be large and efficient, which again increases mass and structural complexity. Every subsystem designed to solve one problem creates another demand somewhere else. The system grows heavier, more fragile, and more energy-hungry. When these factors are combined, propulsion, fuel, shielding, thermal control, life support, structural integrity, the total energy requirement reaches scales that rival stellar outputs. An interstellar invasion is not merely a matter of desire or technological advancement. It demands resources so extreme that they reshape entire planetary economies or star systems just to send a single mission. The fantasy of fleets crossing the stars ignores these numbers. But numbers do not ignore reality. They expose the immense, almost prohibitive cost of such travel. Energy is not just a hurdle. It is the towering barrier that stands between imagination and execution, enforcing limits with mathematical indifference. Time is the barrier that quietly crushes interstellar ambition. Distance and energy are dramatic obstacles, but time is the slow, relentless force that erodes purpose itself. Even if a civilization could gather the energy required and engineer a vessel capable of surviving the journey, the clock would still rule the mission with merciless authority. Traveling at a fraction of the speed of light sounds impressive, but even at 10% of that speed, reaching a star system 10 light-years away would take a century. Not months, not years, 100 years. That means the individuals who launched the mission would never see its arrival unless they had solved the biological limits of aging or placed their trust in generations yet unborn. The mission becomes larger than a lifetime. It becomes larger than a culture. Stretch that to more distant stars, and the timeline expands into thousands of years. Civilizations on Earth struggle to maintain political stability for decades. Empires rise and collapse in centuries. Languages evolve. Beliefs transform. Priorities shift. Now imagine sustaining a unified objective across millennia. The society that approved the mission might fragment, evolve, or disappear entirely before the craft reaches its destination. Communication introduces another fracture. Messages cannot travel faster than light. A vessel moving many light years away becomes increasingly isolated. Orders, updates, or changes in strategy would take years to arrive, and just as long for responses to return. Coordination becomes impossible in real time. The farther the craft travels, the more it becomes a relic of a past decision, carrying intentions that may no longer reflect the reality of its origin world. Even relativistic time dilation does not solve the strategic problem. While travelers moving near light speed might experience less time personally, the external universe would continue forward. Entire eras would pass on the home world. Political landscapes would transform. Motivations that once justified an invasion could dissolve. By the time the vessel arrived, the target planet might be technologically transformed, environmentally altered, or no longer strategically relevant. Long missions demand unwavering commitment across spans that exceed ordinary historical continuity. That is not simply an engineering challenge, it is a sociological and psychological one. Maintaining resources, belief, and purpose over thousands of years requires a stability few societies demonstrate even over short periods. Internal conflicts, shifting priorities, and unforeseen crises could redirect attention long before arrival. Time also multiplies risk. Systems degrade, materials fatigue, microscopic failures compound. Over centuries, even minor imperfections become critical. Maintenance would require self-sufficient ecosystems of repair and adaptation, essentially creating a floating civilization rather than a simple vessel. The complexity deepens again. Interstellar conquest is not just a matter of reaching another world. It is a matter of surviving the passage of time without losing direction, cohesion, or relevance. And time does not negotiate. It stretches across the void, silently enforcing patience on scales that dwarf ambition. Even if energy and speed could be managed, time remains the ultimate filter, eroding the likelihood that any invasion launched across the stars would still make sense upon arrival. Intelligence is often imagined as a straight line toward domination. The more advanced a civilization becomes, the more powerful and aggressive it must be. That assumption is rooted in human history, where technological progress has often amplified the capacity for conflict, but projecting that pattern onto the cosmos is a mistake. Advancement does not automatically equal conquest. In fact, the higher the level of intelligence, the more irrational large-scale invasion begins to look. An advanced civilization capable of manipulating enormous energies and sustaining itself over astronomical timescales would likely understand efficiency at a profound level. War across interstellar distances would be one of the least efficient uses of resources imaginable. The energy investment alone would be staggering. The logistical complexity would be extreme. The uncertainty of outcome would be enormous. For what reward? Raw materials exist in abundance throughout the universe. Uninhabited planets are far more common than inhabited ones. Asteroids contain metals and elements without the complication of resistance. The incentive to invade a populated world collapses under economic logic. Another uncomfortable realization emerges from this line of reasoning. Aggression at planetary scale may be a sign of immaturity, not advancement. Civilizations that survive long enough to master interstellar-level technologies must likely solve internal instability first. They would need to overcome self-destruction, resource collapse, and internal conflict. A society that still clings to expansion through violence may not survive long enough to develop the capacity for star-spanning travel in the first place. There is also the question of risk. Approaching another intelligent civilization carries unknown dangers. The target world could possess defensive technologies, biological hazards, or unpredictable responses. Even if technologically inferior at first glance, a defending civilization might adapt quickly. Launching an interstellar invasion means committing immense resources without guaranteed success. From a purely rational standpoint, that gamble appears reckless. A further harsh truth challenges popular imagination. If a civilization truly had the capability to cross vast interstellar distances easily, it would operate on technological levels so far beyond ours that detection or resistance would be meaningless. There would be no dramatic buildup, no cinematic confrontation. The power imbalance would eliminate the spectacle entirely. The absence of visible signs suggests not hidden fleets, but the overwhelming difficulty of the task itself. The image of alien invasion persists, because it mirrors human instincts: competition, territorial expansion, dominance. Yet intelligence, at its highest level, may evolve beyond those impulses. It may prioritize sustainability, knowledge, or internal flourishing rather than conquest. The more advanced a society becomes, the more it might recognize that survival in a vast and resource-rich universe does not require seizing inhabited worlds. Projecting humanity as violent chapters onto hypothetical extraterrestrials is emotionally compelling, but logically weak. Intelligence does not guarantee hostility. Power does not demand invasion. When examined through cold reasoning, the assumption that advanced beings would cross unimaginable distances simply to conquer begins to look less like inevitability and more like a reflection of human psychology rather than cosmic reality. The idea of alien invasion survives, not because it is scientifically strong, but because it is psychologically satisfying. It gives the unknown a face. It gives the universe intention. It transforms cold, silent space into a stage filled with motives, strategies, and looming threats. That narrative feels familiar because it mirrors human history. Empires expand, powerful nations dominate weaker ones. Technology becomes a tool of conquest. It is easy to project that pattern outward and assume the cosmos follows the same script. But that projection says more about human nature than about extraterrestrial reality. Fear of invasion is rooted in memory centuries of territorial conflict, colonization, and war. The mind takes those experiences and scales them up. If humans once crossed oceans to conquer distant lands, surely advanced beings might cross stars to conquer planets. The analogy feels logical. Yet it ignores the vast difference in scale and constraint. between oceans and interstellar space. Stories of invasion also feed a deeper instinct, the need for significance. An alien threat implies importance. It suggests that Earth matters enough to be targeted. It frames humanity as a central player in a cosmic drama. That emotional appeal is powerful. Isolation is far less exciting. A quiet universe, governed by impersonal laws and immense distances, offers no dramatic villain and no heroic resistance. It offers indifference. The mind resists indifference. It prefers narrative over neutrality. A hostile universe feels alive. A silent one feels empty. So imagination fills the void with fleets, empires, and intentions. Yet physics remains unmoved by these stories. It does not assign motives. It does not reward drama. It enforces distance, energy limits, and time without emotion. There is also the influence of repetition. Popular culture has reinforced the invasion archetype for generations. Massive ships, blotting out skies, coordinated attacks, humanity united under threat. These images embed themselves deeply, becoming default expectations rather than speculative fiction. Repetition breeds familiarity, and familiarity breeds perceived plausibility. Another psychological factor is control. A defined enemy feels manageable. If there is an invader, strategies can be imagined. Defenses can be planned. Even defeat has structure. But a universe constrained by incomprehensible scale offers no opponent to confront. It simply exists, vast and indifferent. That reality is harder to emotionally process than a clear external threat. The invasion myth thrives because it aligns with instinct and storytelling tradition. It translates the unknown into something emotionally digestible. Yet when stripped of narrative and examined through calculation, the scenario weakens. The distances are extreme. The energy costs are prohibitive. The time scales are destabilizing. The motivations become questionable. What remains is not a dramatic battlefield among the stars, but a cosmos governed by constraint. The psychological comfort of a threatening universe fades under logical scrutiny. And what replaces it is not terror, but perspective and understanding that the greatest barrier between civilizations is not hostility, but the immense and impersonal architecture of reality itself. The most unsettling truth about the cosmos is not that it is filled with enemies, but that it is overwhelmingly indifferent. The universe does not notice, it does not judge, it does not conspire. There is no hidden agenda to reach Earth. The barriers that prevent alien civilizations from arriving are not mistakes, accidents, or mysteries. They are fundamental, unavoidable features of reality. Distance, energy, and time are not negotiable. They enforce separation without malice or purpose. Earth is not protected by luck or secrecy. It is protected by scale. The stars are so far apart that any attempt to traverse the space between them becomes a calculation in futility. Even civilizations capable of harnessing colossal amounts of energy would face challenges that multiply with every additional kilogram of mass, every extra year of travel, and every incremental fraction of light speed. The universe is vast beyond comprehension, and that very vastness acts as a natural deterrent. Nothing can bridge it without extraordinary resources and planning that may be impossible to sustain across the vast stretches of time required. Energy demands alone enforce separation. Accelerating objects close to the speed of light requires amounts of energy that are almost unimaginable. Larger objects require exponentially more energy. Every attempt to shield, sustain, and navigate a craft increases its mass, which further increases the energy needed. Even if a civilization has mastered technologies beyond human imagination, the laws of physics create an invisible wall. The universe is not hospitable to shortcuts. It punishes assumptions that effort alone can overcome distance. Time is another silent enforcer. Even if propulsion and energy are somehow addressed, the passage of years, decades, or millennia introduces unpredictability. Civilizations are not static. They evolve. They rise and fall. Missions that require generational commitment risk being orphaned by history. The intentions that launch the journey may no longer exist upon arrival. The cosmos does not pause to accommodate desire. It continues relentlessly. The vacuum of space adds its own trials. Particles, dust, and cosmic radiation at relativistic velocities are deadly. A single collision with a speck of matter at near light speed carries the energy of an explosion. Every protective measure increases mass, which increases energy demand. The challenges multiply like a cascading chain reaction. There is no simplification that can bypass this reality. The universe is not empty, it is lethal, indifferent, and uncompromising. The absence of alien contact is not proof of their weakness or secrecy. It is evidence of the barriers imposed by distance, energy, and time. The cosmos operates on rules, not drama. Those rules separate worlds, making casual interstellar invasion virtually impossible. This indifference is not comforting, but it is clarifying. There is no cosmic conspiracy, no hidden fleet lying in wait, no strategic plan to bypass physics. The most powerful protector Earth has is simply the architecture of reality itself. Distance, energy, and time are guardians, impartial and relentless. They enforce separation not with intention, but with certainty. To understand this is to grasp the harshest truth. The universe does not bend to desire. It does not negotiate. It does not reward drama. It operates on principles that are absolute, and those principles make alien conquest of Earth extraordinarily unlikely. The cosmos is indifferent, and in that indifference lies a subtle kind of protection, a protection rooted in the sheer immensity and unforgiving nature of existence itself. Stop fearing alien invasions and start respecting the scale of reality. When the obstacles of distance, energy, and time are fully understood, the fantasy of fleets arriving from distant stars collapses. The universe is not plotting against Earth. It is indifferent. It is immense. It enforces separation through immutable laws. Recognizing that fact changes the way thinking operates. It shifts focus from imagined threats to the constraints that truly govern possibility. Understanding these barriers requires discipline. It requires asking the hard questions. What is actually achievable? What is physically realistic? How does energy scale with mass and velocity? How does distance affect strategy? When answers are calculated rather than imagined, myths begin to unravel. The process is not comforting, it is demanding. It forces a confrontation with reality that many prefer to avoid. But clarity always begins with honesty, not with stories meant to excite emotion. This mindset shift has consequences beyond the topic of extraterrestrials. It teaches a rigorous approach to problem solving. Every decision, every plan, every expectation can be measured against the limits imposed by nature. It encourages skepticism toward grandiose claims and unrealistic scenarios. It disciplines the imagination to operate within possibility rather than indulge in wishful thinking. It transforms fear into understanding and anxiety into calculation. One of the harshest lessons is realizing that desire does not equal capability. Just because something seems compelling or urgent in the imagination does not mean it can occur. Ambition cannot override the laws of physics. Resources cannot bypass energy constraints. Time cannot be shortened to fit narrative convenience. Accepting this is a form of intellectual maturity, a refusal to let hope or fear dictate belief in the face of evidence. Another important realization is that absence does not imply conspiracy. The universe may feel quiet, but that quietness is not a void filled with hidden enemies. It is the natural state of a cosmos governed by law, distance, and limitation. What is invisible is often constrained, not malevolent. Understanding this distinction is liberating. It shifts attention from imagined threats to actual factors that matter, strategy, preparation, and the recognition of constraints. The takeaway is clear. Approach challenges with an understanding of limits. Measure ambition against the reality of scale. Evaluate risk against physical possibility. Distinguish between what is conceptually exciting and what is physically achievable. That discipline transforms thinking, not only about space, but about life. It teaches that clarity, logic, and realism are more powerful than drama, fear, or speculation. When the mind internalizes these lessons, myths lose power. Fear of alien fleets fades, replaced by appreciation for the immensity of space and the laws that govern it. The realization that distance, energy, and time act as unyielding barriers sharpens perception. It provides a framework for understanding challenges on every scale, whether cosmic or personal. This shift is not trivial. It is a call to rigorous thought, to intellectual honesty, and to respecting the structures that govern possibility. By accepting reality as constraints, thinking becomes sharper, reasoning becomes more precise, and imagination becomes disciplined. The universe is vast and indifferent, but understanding that indifference gives perspective, clarity, and power. Myths crumble, fear dissipates, and the mind gains freedom through comprehension. It is time to stop surrendering your mind to spectacle and start demanding clarity. Belief in alien invasions persists because it satisfies emotion, not reason. It thrills, it terrifies, it entertains, but it ignores reality. The universe does not conspire. It does not pause to stage drama. It operates according to strict laws that cannot be bent by desire, imagination, or fear. Recognizing that truth is a challenge, but it is also empowering. The first step is to take responsibility for how thinking is shaped. Myths survive because the mind prefers narrative over neutrality. Human instincts favor patterns, motives, and faces in the unknown. Stories of fleets and empires give the cosmos familiarity, but that familiarity is false. It gives the illusion of understanding without requiring engagement with reality. To overcome that, it is necessary to confront the scale, the energy requirements, and the passage of time that make interstellar invasion virtually impossible. This clarity transforms perception. Distance alone is staggering. Energy demands are crushing. Time stretches into millennia. When these factors are acknowledged, the imagined threat collapses. That realization is more than an intellectual exercise, it is a lesson in the discipline of thought. Fear and imagination are no longer sufficient to dictate belief. Numbers, physics, and logic take precedence. That mindset can be applied in countless areas beyond space and problems of life, work, and understanding. Recognizing limits does not equate to pessimism. It equates to strategy. It equips the mind to distinguish between what is possible and what is fantasy. It prevents resources, attention, effort, and energy from being wasted on chasing impossibilities. It trains reasoning to focus on constraints, risks, and outcomes. That shift is profound. It replaces emotional reaction with calculated understanding. It replaces myth with reality. The final truth is blunt. The universe is not out to get anyone, but it is unforgiving. It does not reward drama. It punishes assumptions that ignored its rules. Every barrier, distance, energy, time is impartial. They enforce separation between civilizations and worlds without malice. That impersonal structure is the most reliable protection Earth has against imagined threats. Respecting that reality is not optional if clarity matters. Now comes the challenge. Apply this rigor everywhere. Question assumptions, check calculations, measure ambition against constraints. Do not accept fear as proof. Do not let imagination substitute for analysis. The ability to see clearly through myths, to identify the unyielding rules beneath alluring stories, is a rare skill. It is a skill that separates understanding from credulity. If the mind internalizes this discipline, myths lose their grip. The allure of alien invasion fades, replaced by awareness of scale, law, and limitation. Understanding becomes freedom. Fear is replaced by perspective. Imagination becomes precise, not chaotic. The harsh truth of the cosmos, its indifference and structure, is not a barrier to thought, it is a training ground for it. The call is simple and uncompromising. Confront reality honestly. Measure possibility against constraint. Reject stories that conflict with the laws of existence. Exercise intellectual courage. Accept that the universe is vast, indifferent, and absolute. Once that is internalized, myths crumble, fear dissolves, and the mind becomes powerful through comprehension. Your perspective shifts, your reasoning sharpens, and your understanding of the universe and your place within it achieves a clarity that no fiction can ever provide.